Good morning, everyone. My name is Saurabh and today I'm presenting a statistic data-driven initiative designed for Qantas Airline, one of the Australia's most recognized and respected aviation brand. Our topic today is fuel efficiency analysis, a project that applies the power of business intellectual and predictive analytics to improve Qantas of personal efficiency, reduce cost, and support its sustainability commitments. In this presentation, I will demonstrate how a hybrid analytic framework, one that integrates machine learning and predicts with real-time business intellectual dashboards, can turn Qantas complex operational data into actionable intelligence. Ultimately, this solution is not just about reducing fuel consumption, it's about remaining how data can fuel smarter, cleaner, and more profitable aviation. Fuel is one of the largest and most volatile cost driven in the aviation industry. It typically accounts for 20 to 30% of total airlines operating cost. For Qantas, this translates to several billions dollars annually in fuel expenditures. Currently, Qantas employ a range of advanced operational systems, but fuel data is often scattered across the different platforms, from aircraft's telemetry to flight logs and maintenance report. As a result, the company primarily reacts to inefficiency rather than predicting and preventing them. Our proposals initiative focus on bridging the gap by building a hybrid data solution. Qantas can integrate predictive analytics to forecast optimal fuel usage and real-time business intellectual dashboard to monitor consumption trends instantly. This approach will allow the airlines to move from reactive decision making to productive, insights driven operation, resulting in measuring cost saving and enhanced sustainability and improved decision quality. Now, let's start by identifying the current challenges. Although Qantas is globally recognized for its operational excellence, the airlines faces ongoing complexity common across the industry. Fuel consumption varies drastically based on aircraft type, weather condition, altitude, flight duration, and taxi delays. While Qantas collect huge volume of such data, the insights are often fragmented and delayed. For example, a flight fuel report might only be analyzed after completion, meaning there is limited opportunity to optimize performance in real time. Moreover, different departments such as operation, maintenance, and flight planning may use different systems and create information soils. This lacks in integration means that the pilots and planners rarely have unidentified views of all the factors affecting fuel efficiency. Constantly, the opportunity to save fuel and therefore reduce emission are often missed. In short, I want to say this that Qantas has the data but is not yet being fully leveraged for predictive and operational insights. Let's translate that challenges into business term. Qantas spends an estimated AUD of 5.5 to 6 billion per year on aviation fuel. To prevent this into a perspective, a 1% improvement into fuel efficiency could save the company between 50 to 70 million annually. This magnitude of saving demonstrates that even small data-driven optimism can create significant financial impact. But this challenge is not only financially, it's also a sustainability dimension. The aviation industry is undergoing pressure to minimize the carbon footprint, and Qantas has pledged to achieve net zero emission by 2050. Optimizing fuel consumption directly support both operational cost control and environmental stewardship. Therefore, the strategic challenges for Qantas is clear. How can the airlines utilize business intellectual and analytic to get real-time visibility, predict inefficiency before they occur, the achieve measurable costs and the environmental benefits simultaneously? Our solution poses a hybrid analytic framework that combines the predictive power into machine learning with quality of real-time business intellectual dashboard. Predictive analytic components. A machine learning model would be developed using historical profile data. Variables such as aircraft type, route length, altitude profile, weather, load weight, and taxi duration would be analyzed to forecast estimated fuel uses for upcoming flight. When an anomaly or inefficiency is detected, for example, an aircraft expected to use more fuel due to wind or weight, operational can proactively plan to offset it. Real-time business intellectual dashboard components. A Power BI or Tableau dashboard would provide live monitoring of key fuel performance indicators. This dashboard would integrate a large sensor data from aircraft system, ATC update, and weather feeds to provide up to the minute visibility for pilots, flight planners, and fuel managers. Together, these components create a closed loop intelligence system. Predictive insights inform planning before departs. When live dashboard track actual performance during flight and post flight data is fed back to the continuously refine the model. This hybrid approach ensures that the data insights are both forward looking and operationally actionable. From a technical standpoint, this initiative can build on existing Qantas cloud and analytic infrastructure with minimal disruption. Here's how the architecture works. Data ingestion layer. Real-time flight and engine data are transmitted through LOT enables aircraft system. This includes sensors tracking altitude, airspeed, fuel flow, and engine temperature. External data such as weather and air traffic conditions are also streamed in via APIs. Data store layer. All incoming data is securely centralized in the cloud-based data lake such as Microsoft Azure Data Lake or AWS S3, ensuring scalability, compliance, and accessibility. Analytics layer. Using Azure machine learning or Python-based machine learning, predictive models are trained to estimate optimal fuel uses for each flight under various conditions. And the BI visualization layer, a Power BI visualization dashboard, aggregates process data into initiative visual. KPI includes fuel burn per kilometer average from optimal consumption, route efficiency index, and CO2 emission reduction process. This technical framework transmits raw data into real-time technical intelligence, assembling anytime, anywhere by authorized stakeholders. Now let's explore the implication of this initiative in both financial and organization terms. Financially, the implementation requires an upfront investigation at AUD 2.5 million. This covers data integration, machine learning model, business intellectual tool licensing, and cloud infrastructure. An additional of 200,000 will be needed for user training and change management workshop to ensure all teams can efficiently use the system. However, the projected return on investment is sustainable even with a comprehensive 1% improvement in fleet-wide fuel percent equates to approximately around 50 to 70 million in annual saving. This means a full ROI can be achieved under 9 months post development. Organizationally, this initiative promotes data transparency across department. Pilot gain access to route-based fuel benchmark, planner receive predictive forecast, and engineers can detect early sign of engine inefficiency. The system also reduces decision latency, meaning Qantas can respond to inefficiency in near real time rather than delays or a week later. In essence, the initiative is not just a IT project, it's a company-wide transformation in how data drives operational excellence. This transmission will create a ripple effect across Qantas' internal ecosystem. Flight operational pilots will receive more accurate fuel load recommendation before departure, optimizing both safety and efficiency. Maintenance team predictive analysis will identify abnormal consumption patterns, helping detect underperforming engines or system outages. Flight planning data insight will allow planners to recommend route and altitude that balance time, cost, and fuel consumption. Management executive gain transparent performance metrics in real time, improving governance and strategic decision making. In the longer term, the initiative forecasts a data culture where decisions are based on analytic rather than institute. This directly aligns with the Qantas cooperative values of innovation, accountability, and sustainability. It will not only improve efficiency but also strengthen employees' confidence in data-driven process. The proposed implementation and roadmap spans approximately 2 years, divided into three major phases. For the phase 1, pilot 0 to 6 months, begin with a controlled pilot involving select aircraft types such as Boeing 787, Dreamliner, and Airbus A330. During this phase, data pipelines are established, historical data is cleaned and prepared, an initial predictive model and dashboard prototype are developed. Feedback from operational teams will help refine the usability and relevance dashboard of KPIs. Phase 2 integration and rollout. This goes from 6 months to 12 months. In this phase, real time data connections are activated. The BI dashboard is rolled out into operational control central and fleet manager staff undergo training session. Predictive models are tested for accuracy and reliability under different flight conditions. As on the phase 3 scaling and optimization, which goes from 12 to 24 months, the solution is scaled across the full Qantas fleet. Machine learning models are fine-tuned with live feedback data and integration, and Qantas sustainability reporting framework is completed. Performance reviewing ensure that the platforms continues to evolve with the operational needs. This fresh approach minimizes risks and allows every value demonstrate building stakeholder trust and the momentum. The benefits of this hybrid BI interactive are multifactored and extended across the financial, operational, and environment domains. The financial gains are projected around 1 to 1.5% reduction in total fuel consumption could be saves Qantas around 50 to 100 million annually. To the operational efficiency, which improve route optimization and proactive planning can increase aircraft utilization and reduce delays caused by the inefficiency. Environmental benefits, fuel optimization directly translate to reduction carbon emission around 6,000 tons of CO2 annually, contributing significantly to Qantas sustainable goals. Data-driven decision making with across the accuracy, visualization insight, decision at every level, from pilot briefing to executive meeting, become faster and evidence-based. At looking forward to the future, this project lays the groundwork from a fully intelligent airlines ecosystem with the rapid advancement of AI and generative AI. Qantas can evolve this system into a self-learning platform. For instance, generative AI could automatically analyze post-flight data and generative narrative summarized from performance, highlighting reasons for devastation and suggestion corrective actions. Additionally, integration with the satellite-based weather prediction could provide more precise route optimization, avoiding turbulence and jet stream that increase fuel burn. The same infrastructure could also support predictive maintenance using AI to forecast components wear and schedule repairs proactively reducing the unplanned downtime and improving fuel reliability. In future, this platform could even support AI-driven flight scheduling, optimizing crew assessment, aircraft rotation, and gate usage based on predictive demand analytics. In short, this initiative is not just a short-term project; it's a long-term digital foundation that will support Qantas' continued innovation and reliance. To conclude, this proposal represent a strategic opportunity for Qantas Airlines to integrate data intelligence into the very core of its operational by adapting a hybrid BI predictive analytic framework. Qantas can enhance operational efficiency, achieve sustainable cost saving, strengthen sustainability performance, and embedded a data driven culture across all organization levels. The investment is modest compared to the returns not only financially but also in reputation, innovation, and long term resilience. This initiative direct aligns with Qantas' strategic pillars that are safety, customer experience, operational excellence, and sustainability. In exchange, Qantas can turn its data into the competitive advantage, transforming information into insight, insight into action, and action into measurable result. Before I conclude, I would like to acknowledge the source and industry framework that informed this proposal, including research from IATA, Detroit, Microsoft Aviation Case Studies, and Qantas 2024 Annual Report. So, this institute is realistic, data driven, and aligned with both global best practice and Qantas' vision of a smarter aviation future.